Good morning and good afternoon, everyone, and welcome. It's a real pleasure to see such a strong turnout for this workshop on GIS application in archaeology, history, and challenges, and the start of our first GIS clinic. Whether you're completely new to GIS, have experimented with it in your own research, or are already integrating spatial analysis into your projects, you are very welcome here today. My name is Azadeh, and I'm the training coordinator for MAHSA project, and I'm very pleased to be your moderator and guiding you through this workshop. We also have our MAHSA and MAEASaM's project members who are going to be assisting with our hands-on GIS clinic later today. This is the seventh workshop that we had organized with our project sister MAEASaM, and it's also our first workshop of the second phase of our both of our projects. And based on the feedback that we received from the last survey we conducted, we decided to dedicate this year's workshop series on step-by-step introductory hands-on GIS sessions delivered online for you. These workshops and GIS clinics are designed to provide practical experience and a solid foundation in GIS concepts and its use in archaeology. Structure of today's session reflects two core intentions. First, we want to situate GIS in archaeology, particularly in South Asia and African continent. What are we doing? What are we not yet doing? What are the structural and practical challenges we face? And how do we compare critically and realistically with global trends? Second, we're going to move the discussion into the practice and start our first hands-on GIS. The second half of today is being devoted to working with QGIS, and I will talk about that more later on. This is not to be a one-off technical workshop, so it's the first in the sessions of the workshops that we're going to have, and hopefully we're growing a community who will stay with us and continue with us in our upcoming clinics. To open the workshop now, I would like to invite principal investigators of both of our projects, first Professor Cameron Petrie, followed by Professor Paul Lane, to start the workshop by welcoming everyone.
Thank you so much for that warm introduction, Azadeh, and thank you so much everyone for joining. I've been sitting here watching the numbers of people increase while we've been talking at the beginning. It's so fabulous to see over 200 people are with us. I'd just like to say on behalf of the MAHSA project, it's so wonderful to see so many familiar names and faces from India, Pakistan, and other countries that we know. We look forward to the opportunity of interacting with you over the day, and there'll be a range of members from the MAHSA team, and hopefully plenty of opportunities to ask questions. And if this is all things that keep being interesting to you, we can continue to have conversations into the future. But yeah, I'd just like to thank Azadeh for organizing everything with the members of the MAHSA team, particularly today. I know that there's going to be additional thanks given for others, but it's a really fabulous opportunity to, in many ways, share with you all some of the skills and methods that we've been using. Introductory work to GIS. I know some of you will have much more elaborate experience already, but hopefully everything that we cover today will be of interest in terms of the types of skills and methods that can be used to document and geospatially locate archaeological heritage. So on behalf of me and on behalf of the MAHSA team, I'd just like to thank you all for joining and wish you all a good and enjoyable workshop for today. Thank you very much. I'll hand over to Paul Lane now.
Good morning, good afternoon, everybody. Fantastic to see so many people here. And I'd just like to, again, echo thanks to Azadeh and the MAHSA team who've done so much of the heavy lifting on the organization of this particular workshop, but also thanks to the members of the MAEASaM project, the Mapping Africa's Endangered Archaeological Sites and Monuments project that I coordinate. But several of the team members will be here as well and can be contributing to the workshop. I think it's really fantastic that we have these collaborative workshops where researchers based on the African continent and those in South Asia are engaging and looking at the issues relating to GIS and its use and wider concerns about digitization of heritage records. There is so much commonality, but there are also differences as well, and I think we can learn from each other from that. And I really appreciate that kind of cross flow of information and the interaction, even though it's a digital one, that these workshops provide. So I'm really delighted by that. I won't say anything more other than to say welcome to everybody. I think it's a fantastic program. For those of you who are Africa-based, and if you happen to be going to the Pan-African Archaeological Congress in Maputo in July, we will also be running on the day before the formal conference begins, a day-long session as well. So a chance to get some more hands-on experience if you're going there. And we have also several sessions with various papers on the whole MAHSA-MAEASaM project that I hope that you may also be interested in. I'll hand back to Azadeh, and very good luck with the workshop to everybody.
Thanks very much, Paul and Cameron. So we can start the sessions. Just before doing that, so what we're going to do today is mainly to talk about GIS. Why GIS and why now? GIS is no longer an optional add-on in archaeology. It has become central to how we work as archaeologists, from mapping and pattern analysis to heritage monitoring, and use it as a communication tool through digital reconstruction and story maps. Yet while GIS tools have become more powerful and more accessible globally, the way they are used and the infrastructure that supports them varies significantly depending on context. In many parts of the global north, researchers benefit from extensive publicly available data sets, standardized digital archives, long-term spatial data infrastructure. But in contrast, archaeologists working in the global south, they face very different conditions: limited access to reliable spatial data sets, fragmented and inaccessible archival material, inconsistent mapping standards, etc. And this will create a gap, not in intellectual capacity, but in infrastructure and support. And it raises important questions. How do we build robust GIS practice under these conditions? What does it mean to produce spatial knowledge responsibly when data sets are incomplete or uneven? How do we move beyond basic mapping toward analytical and interpretive depth? These are some of the questions that frame today's workshop and today's talk. We'll start by a framing talk by Stefania and myself to hear about current application as challenges of GIS in archaeology, generally in South Asia, looking with examples in South Asia and Africa. Then we have three invited guests who will talk to us through different case studies, talking about fieldwork and distribution analysis, landscape analysis and hydrology, and public engagement through story maps and digital platforms. We're going to start with our first talk, and that's a talk by Stefania and myself. So we're going to talk about the challenges and use of GIS in South Asia and Africa. Just to note that few of the slides that I have here, especially at the beginning, might be very introductory for those who have knowledge of GIS and use GIS in their work, but we wanted to make sure that everyone starts with the same understanding before we start our interactive clinic. And I wanted to make sure that we cover the basics. Archaeological data are inherently spatial, and GIS allows archaeologists to ask large-scale questions, such as their relationships to each other and with their landscape and environmental factors. It allows us to plot sites, data, and maps and understand spatial patterns in the past, to work across large landscape and carry out settlement analysis. You can integrate archaeological data with other related data, such as environmental, infrastructural, urban planning, and so on. It can also be used as a repository of site data for the management of sites. It's a tool that most use for visualization. You can visualize and can communicate the visualization and interpretation with others, both for research and heritage protection. We often in our work need to deal with a huge amount of data, and with GIS software, we can combine geographical information, displaying geographical data of where your sites are located, with additional data about your sites, such as their function, their period, their condition, etc., all in one place. And being able to store and interpret, see and interpret both of this data in one place has been super helpful for archaeologists. The plotting and finding sites on maps is not something, it's something that archaeologists have been doing for the majority of the 20th century, plotting locations on a flat 2D maps to explore and interpret spatial component of sites. However, the analysis of this site record spatial information was largely restricted to static distribution maps and attempts to understand similarities, trends, differences, but visual comparing patterns. While these maps were invaluable, the interpretations were often limited to what could be observed by eye. Quantitative spatial analysis was time-consuming and in many cases impractical without digital tools. With the development of GIS, this changed significantly. Instead of simply displaying where sites are located, especially when dealing with large data sets, archaeologists can now analyze why they are located, where they're located. GIS allows for the integration of multiple layers of data, enabling more sophisticated spatial modeling. This shift moved archaeology from descriptive mapping toward analytical spatial science, where patterns can be measured, relationships statistically evaluated, and predictive models developed to better understand past human behavior. Just a very simple use, when you are able to plot survey sites on a map just by looking, you can start to think and ask questions about your data sets. For example, when you have the legacy data and published survey data set plotted, you can have a look and see at the areas where they haven't been surveyed and ask the questions where there are no sites there, or if seeing the site location is because those areas haven't been surveyed. GIS does essentially three main things. First, it allows us to store almost any type of information and link it to your spatial features, whether those are points, lines, and polygons, and Jack will talk about that later on today. Second, it allows us to analyze data spatially, and third, it allows us to present and visualize the information clearly. One of the most important aspects of GIS is that patterns and trends can be identified when data is analyzed spatially. Instead of just looking at where sites are located, we can begin to understand relationship distributions and correlations across a landscape. How it does that? GIS relies on GIS relies on concept of thematic mapping. This means we can bring together multiple layers of geographical information geographical spatial data in one place, and each layer represents a specific theme or aspect of the study area. For example, you can study and include environmental data such as hydrology, topography, soil types. You can also add information on current land use, administrative boundaries, and of course have your site data there. And by combining all these layers, GIS gives us a powerful tool to understand the relationship between different features of the sites, between the sites among themselves, and to look at any, and also with the sites where located in the larger landscape. One of the simple or the most common use of this layering of information, and what's for us is used a lot at MAHSA, is to layer and georeference historical maps, specifically Survey of India historical maps. I'm not going to talk about that. We have a workshop dedicated on that, and it's on our YouTube. You can digitize features that are important archaeologically from these maps, and then you can see them on Google Earth imagery and study them furthermore. The landscape has been significantly modified in different parts of the world, specifically in South Asia, with the introduction of large-scale mechanized agriculture and irrigation channels and rapid urbanization. So these maps, for the example of South Asia, help us they map the landscape before these changes, and they can help us to identify many sites from, these examples are mainly on mounds, but other type of sites from these maps. In Africa, while the majority of historical maps are at small scales and often in a region like Sudan from which this example map is derived, not very detailed, it is still worth exploring these maps to identify archaeological sites by using the legend symbols and also reading annotations. In this case, once the map was georeferenced, it was possible to use Google Earth to further explore the areas. And in this case, it's the areas annotated as Anak graves. And in fact, in that area, we detected hundreds of stone cairns. As you can see from the bar chart, it is not often possible to so clearly identify site annotated on these maps after looking at satellite imagery to verify their locations and even their existence. This is mainly due to spatial inaccuracies when working with small-scale maps. We can also combine these historical maps with machine learning and deep learning. A work combining historical maps and deep learning enabled the detection of nearly 6,000 mound features in India and Pakistan. And this significantly improved our understanding of Indus and later settlement distribution. By enabling large-scale automated extraction from historical maps, this approach opens new possibilities for archaeological research, documentation, and monitoring, with strong potential for application in other similarly mapped regions. Other applications of GIS are density analysis. And here I have two examples of when you're looking at site level. If the information is recorded from artifacts at different part of the site, you can then do a density analysis of where is the most densely artifacts are located. And if you're looking at more regional level, use of heat map also helps to show density of site locations. In this example, red is showing high and blue showing low density. And the bottom picture is showing the legacy data, surveyed legacy data recorded before 2009, comparing with the top image after 2009 and showing the density of site. It is also helps us GIS for the heritage management, and it informs planning decisions. Sharing archaeological information with concerned local authority who are responsible for land classification, urban planning, and etc. can help us with that. This is an example of data that MAHSA has from District of Punjab, coming from published data, historical maps, and remote sensing. I think someone has the annotation on. Dan, if you can ask them to remove that, please. So the data is from different sources and plotted on the map. And then subsequently, we share this data with the authority responsible for studying and allocating land classification. And this is with the hope and aim that this may help guide surveys on the ground and enrich land classification to better protect archaeological sites. Throughout history, environment is one of the main factors that have been affecting distribution of people. People have been meaning to minimize energy costs and maximize proximity to resources, for example, to good soil, rivers, and water sources. And these environmental and external factors influence people and behavior of people and left patterns in the space. There are many different works done to study these patterns. And on this slide, there is a work done from Ajit Singh et al. In 2017, and they've studied evolution of major rivers in the western Indo-Gangic plains and their effect on the urban scale settlement of the Bronze Age Indus civilization. These sites have been linked to major rivers, yet many large settlements lie far from active channels. In their study area, their work shows these cities were built along a former course of the river that had already dried up, meaning Indus settlements developed along a stable, abandoned river valley rather than active river system. There are also many other works done for hydrological reconstruction and using of GIS. And one of our guest speakers, Arno, who will be talking later on, will be showing us the use of GIS for this type of work. Another use is when you find the sites, either from the maps, unknown sites, especially, but also known sites, but with the correct location, and then you will be able to use this information for the monitoring and better protection of the sites, to do the risk assessments and support for cultural resource management in this way. Today's use of GIS is more sophisticated, other than kind of like a manual monitoring, and it enables archaeologists to stimulate and detect environmental changes over time. And this exact example shows the work done by Konetsa et al. In 2022. In this work, the authors present an integrated workflow combining big Earth data and spatial analysis in Google Earth Engine to automatically detect cultural heritage sites threatened by agricultural expansion. Unlike earlier methods focused on general land use change or looting, their approach targets cumulative land cover change and agricultural encroachments, a widespread risk not previously addressed to fully automated techniques. And to explain a few other examples, I pass on to Stefania to go over the next few slides.
Good morning. Thank you, Azadeh, and thank you everybody in the room. Just to give the comparative perspective, we have similar type of studies, but at the same time, as Paul was saying earlier, different in an African context, and we have a growing number of papers published on various analytical techniques that make use of geospatial data. This is a very recent publication from 2025 by Mahmoud and others, and it's an application of machine learning for the detection of land use, land cover changes that can assist us in identifying threats and developing threats in and around identified archaeological sites. And here you have an example of the workflow and the results of comparing two different types of images, a before and an after, and an example of a zoom-in image using Google Earth, actually, and other type of imagery to compare what is happening around a specific couple of sites that are threatened by quarrying. Machine learning has also been used in an African context, and this is the pioneering work of Tabeng, the results of his PhD dissertation published in 2019 that looked at the identification of archaeological sites not by the direct remains in terms of architectural remains, but in this case a study that looked at how it is possible to identify vitrified and non-vitrified dung deposits in Southern Africa, specifically in the Shasha-Limpopo. And there was a comparison here of two different types of machine learning approaches using support vector machines and random forest. So again, another African case study of the advanced analysis used. Another type of analysis that one can do once they have data actually that details, in this case, the outline of archaeological sites like stonewalling, Sototswana sites in South Africa, acquired through LiDAR, it is possible actually to bring this type of analysis a step further. And this is what Azadeh was referring to, is lacking a lot actually in the context in which we work, but it is happening. A recently published study, again, by Ndisi Siteleki, on visibility analysis of cattle dung deposits in Southern Africa, looking at how cattle may or may not have been concealed within a settlement in the Southern African landscapes. And the link to the paper is actually there. For what concerns predictive modeling, and this is the modeling that we do when we have a known distribution of sites, to actually predict where sites that we haven't found on the ground could be located based on a number of known parameters, mainly environmental, but also social parameters. This is a standard type of analysis in any GIS package, and it can be applied to archaeology. In this case, we have here demonstrated it by showing you two maps. One is a predictive model created by Akimboala Kintayo for the Mbeya region of Tanzania, where he extracted information on a number of Stone Age sites in this region and then created a prediction of where these sites may be located. And as you can see, the map has got different color scales where the prediction would be high, or the possibility of sites there would be high, and where it would be low. And then obviously these kind of results need to be verified on the ground. And on the right-hand side, we have a map where a similar approach was used for the prediction of sites in India. And again, with low, medium, and high probability of certain types of sites being located in certain areas. Over to you again, Azadeh.
Thanks, Stefania. So these were only a few examples and applications in which we're using GIS in our context of the area that we work in South Asia and Africa. And our guest speakers, they will dive into a few other examples and I'll talk in detail about their work. But before, continuing, we wanted to also talk about the challenges that we face when we work with GIS, especially in our regions. One of the key challenges we are facing with is the lack of, is that legacy data records were never designed for digital mapping. Most sites from these old records don't have sites coordinates, and the data was entirely text-based. If they have coordinates, they use different methods, and a lot of times they are not precise. So before we could analyze spatial patterns, we first have to convert historical description. And data quality is a major concern. Spatial inaccuracies, missing attribute information, mismatch of coordinate system can significantly affect analysis results. Integrating data from multiple sources requires extensive processing and standardization. Differences in classifications, system, and software compatibilities, different methods of recording can further complicate workflows. We end up with a data set that comes from different sources, and it's not standardized, use different terminology, and as I said, in a lot of cases, the metadata, which gives us information to understand the methodology, the way these sites were recorded, is missing. Integrating data from multiple sources requires extensive amount of work on data processing, cleaning, standardizing, reprojection, and validation. Without data validation, you might get misleading analysis results if you rely on that information, and poor decision could be made, reducing the reliability of your work. This is an example of the work that we've done as part of MAHSA, digitizing one source that we had from SNL in 2003. Only after plotting the sites on the map, we realized that there is an obvious issue with the location. And that was mainly because when the coordinates were recorded, the coordinates were taken from degrees minutes square on the maps. And so the site locations were not accurate using the coordinates on the legacy data, but there were maps in the publication with the correct location of the sites, and then we georeference and use that information. So it kind of shows that when you not validate data, it really can lead to not correct decisions. There was other data challenges that I wanted to talk to you about. This is based on a work done from one of our colleagues from MAHSA, Vaneshri Vidyarthi and Chauhan in 2025. They've worked on digitizing lower Paleolithic sites in India, and these sites were coming from the Indian Archaeology Review. Excuse me. And there was no standardized format for recording these sites. Some entries list only a village name, others mention districts, and a few include distances from landmarks. This uneven level of detail creates major uncertainty in determining exact locations. After plotting of these sites, the authors note that the distribution of sites does not only reflect On this map, you can see prehistorical patterns. It also reflects where researchers were based, which states had stronger economies, where institutions were located, and which regions were politically stable enough for fieldwork. So clusters may not reflect research bias rather than actual may reflect research bias rather than actual prehistoric density. India's political boundaries changed significantly after independence, with districts renamed and states reorganized. This means historical place names do not always match present-day geography. In addition, site names were originally in local languages but recorded in English, and transliteration, distortion, and spelling variation creates multiple possible matches in GIS, and this is another issue that we're faced with. And the example here shows for one site that there are 35 possibilities that you can find when you look on the maps. Other than data quality, data availability is another big challenge. In many regions, data sets may be incomplete, outdated, or restricted due to licensing costs. I'm not just talking about archaeological data, which would very well be the case, but also data needed to do spatial analysis. There is systematic limitation in availability, quality, and accessibility of foundational geospatial data sets. Example of soil properties, land use, land cover, hydrology, elevation models, etc. And this has consequences mainly, it requires skills, times, and financial and human means to make this data sets. As I said, archaeological research increasingly relies on high-quality spatial data sets. However, in many countries in the Global South, these geospatial data sets are incomplete, outdated, or unavailable. Here's an example of well-developed geospatial data systems, such as dataset that may be complementing existing authoritative source, but in data scarce setting are the only source of data. These are the only source of data. Focusing specifically on countries in Africa as defined by the UN Africa region, the spatial coverage and extent of the building footprint datasets used here as an example of baseline dataset needed for heritage management to monitor risk to sites derived from urban expansion, for example, varies considerably across the region, as demonstrated in the figure that compares data from different sources. Differences also exist between the 4 building footprint data products as of January 2023 in terms of their availability and licensing. While all building footprint datasets are conceptually trying to represent the same thing, analysis shows that for African countries, the available building footprints differ considerably in their representation of buildings, with big differences in data products between countries and across urban rural contexts. This creates a situation where end users need to be aware of. So when we have the raw spatial data, we have so that kind of the implication that it has for our work that you have to find this raw spatial data, be able to access it, georeference and digitize it, do the GIS integration, cleaning, and standardization. And then you can then only start to do the archaeological analysis. And it's a very time-consuming process. Overall, these challenges can reduce analytical accuracy, increase project time and financial cost, and impact decision-making processes, therefore ensuring high quality and accessibility. It is also interesting to look at this work done by Mendens Marsh and colleagues published in 2023, examining how GIS is used in archaeology worldwide. The authors analyzed 571 peer-reviewed publications from 1990s to 2022. Their goal was to understand research trends, methodology patterns, and global distribution of GIS applications in archaeology. Geographically, from this study, most research institutions producing GIS archaeology studies are located in the United States and United Kingdom and Western Europe. Africa, much of Latin America, and parts of Asia have relatively few research institutions publishing in this area. However, many archaeological case studies are conducted in the Global South, particularly in the Near East, Central America, and South America. But these are often led by Global North institutions. This suggests unequal patterns of knowledge. Another outcome that I thought would be interesting to highlight here from this work is about how GIS is used in our work. The result shows that GIS is now an essential tool in archaeological research, as much that the keyword for academic papers, people don't even write GIS when GIS is used in their work. Nearly half of the studies, about 49%, focused on spatial analysis. This includes predictive modeling, visibility analysis, density mapping, and landscape studies. About 1/3 of the studies focused on heritage management, 33%, such as site documentation, monitoring, and data organization. Interestingly, the most common uses of GIS were mapping and information management. This suggests that while GIS is widely adopted, it is often used primarily for visualization and data storage rather than for complex spatial modeling. Also, another major issue identified by this research is the lack of theoretical grounding in GIS education. Archaeologists are often trained in how to use software, but not in spatial theory or critical GIS approaches. As a result, GIS can become merely a technical tool for visualization rather than a framework for interpretation. I will hand it back to you, Stefania, to wrap up. Thanks.
We're wrapping up with other challenges. This is not to say that we are discouraging everybody participating in this workshop to use GIS, but to highlight that when you start developing frustration with the difficulties that come with using GIS data for your archaeological questions, you are not alone. We have identified here a number of other challenges, not only the ones that Azadeh talked about, and one of them is infrastructural limitation. GIS obviously requires a substantial infrastructure, especially now that large data sets have become available. It is often not sufficient to just run analysis in a laptop, and not everybody has got laptops of similar power, and not every university has got access to this type of infrastructure. And so obviously, if this investment doesn't happen, even when open data exists, they may not be accessible or usable. Even though we are increasingly using open source GIS software, like the workshop today will demonstrate, there is still a lot of reliance, especially from government authorities, on proprietary software. Proprietary software comes at a very high cost, and it also produces data that may be released at a cost. And this is a problem from the majority of researchers that don't have access to this kind of monetary resources. Although GIS is being increasingly taught at a university level to students in geography and students in archaeology, as Azadeh was mentioning, oftentimes this is not done in dedicated courses, and therefore the theoretical foundations cannot be taught. There is no time for that. And we end up basically training our students in using GIS just to make maps for a project, maps for their dissertation, but not understanding what is the potential, and also importantly, what are the limitations of spatial analysis, in particular using archaeological data. Another thing that we need to bear in mind is that once we start producing increasing numbers of digital information that is derived from spatial analysis, we need to have archiving capacity, and we need to be able to find places where to preserve long-term this data. It is no longer sufficient and actually appropriate to store our data on our laptops. Infrastructure for storing data, though, is costly, is expensive, and not everybody has got access, once again, to the same monetary resources. This brings me to the last set of challenges, which are the ethical challenges of GIS, but I would say that derive in particular from the use of digital data, which are at the core of any GIS. And some of these challenges and some of the questions that we think we should ask ourselves constantly, is what are the research dependency patterns? Knowledge production, and you've seen it in the maps that Azadeh was sharing with us, is dominated predominantly by a few countries. I wouldn't even say global north as we normally talk about it. It's the US and the UK. Why is that so? Should it continue being like that? What should we do to reappropriate basically the study of the archaeology in other parts of the world to be done by people that operate on a daily basis in other parts of the world? If we don't do this, we run the risk of what is increasingly being called digital colonialism, or colonial legacies of research practices and data production. This is a really, really big problem, and that's why we feel very, very strongly that starting to tackle all the challenges we talked about, and in particular, making sure that the new generation of archaeologists is very up to date with applying spatial analysis and geospatial data is very important. And obviously this is an issue because we have unequal access to training, in particular funding, as you can see in this slide, which I have to thank Rebecca Roberts for getting. There is a huge gap between certain countries in the GDP versus how much money a government spends in science and technology, and GIS and spatial analysis is part of that. What can we do about this, or what can we continue doing? And here we go to future directions, even though we have a smaller slice of resources as compared to other countries. What can we do to continue in the future using this type of tools that are going to be used whether we want or not in archaeology and heritage? And so some future directions are here, just thoughts, just bullet points, and please add your suggestions in the chat if you have further thoughts. Is the greater adoption of open source software, the increased use of open access satellite spatial data, Landsat, Sentinel, all of those products at unfortunately small scales, but that are starting to become available even in the geographic areas where we work, and then making big investments in empowering skills through increased and sustained integration of geospatial courses in archaeology and heritage degrees, coupled with capacity building and local training. Recognizing and integrating the research published outside mainstream outlets. If you do a Science Direct research, you will see that all of the GIS-related, spatial analysis-related papers in archaeology are from specific countries. But we know that dissertations are being written, students are writing a lot of research, and we should try and tap to through locally based libraries, online repositories, and see what students and other researchers are producing, not in mainstream. And then synergizing with disciplines and decision-making authorities that already use GIS in the countries where we operate. In particular, land planning, environmental departments in various countries where we operate are already using GIS. We are behind in the heritage sector, so probably opening conversations with these other more resourced departments would probably alert ministries and other important government bodies that GIS is also to be used for heritage management, etc., etc. I rushed through this, and we would be very happy to hear from you what kind of future directions we could take on a daily basis as individuals and as groups of people, so that we can start working together in this direction to make sure GIS is widespread and used critically by archaeologists and heritage practitioners. Thank you.